The purpose of this experiment was to see whether energy loss in a bouncing ball is constant or not, and we hypothesized that yes, the percentage of energy loss relative to the original energy will be constant regardless of the height from which the ball is dropped. So this is the organization of our data, and what we did was average the heights of the second bounces. So we took 4 trials for each original height, and we averaged them to get the second height. And we could calculate the original gravitational potential energy because the height times gravity, which is 9.8 times the mass of the object, which we measured beforehand. And so we could get the original GP, gravitational potential energy, and the second gravitational potential energy by multiplying gravity times the mass times the second height that we had recorded. So that is our data table. So once we had calculated the original gravitational potential energy and the new gravitational potential energies, we wanted to compare them for each specific height that we took so that we could see if the proportion was the same, which would mean that the energy lost is the same, or the percentage of energy lost is the same. So we divided the new gravitational potential energy for each height by the original for each height. And our ratios were similar. They weren't exact, but they were all in the same range.
For our procedure, we chose 4 heights, 1 meter, 0.85 meters, 0.75 meters, and 0.5 meters, and we put a meter stick up against the wall and dropped the bouncy ball from each of these 4 heights, and we then measured the height that the ball reached after bouncing off the floor. For each of these heights, we did 4 trials, which we then recorded. While our data was not exact, it did show that the energy loss of different heights remained relatively constant.